Hello everyone, welcome to Math Companion. So let's start with this question. The very first step for this, we need to write it in indices form. So over here it's going to be logarithm to base 2 x and then to power a half. Then plus logarithm to base 2 x brackets to power a third, which is equals to 2. Now, we are going to make the powers over there with a common denominator so that we'll be able to visualize and see what we are supposed to be doing now, next. Now, then logarithm to base 2 x to power a half can also be written as to power 3 over 6, because for a half and a third, the denominators are 2 and 3, and therefore the LCM for these two is 6. And then plus the logarithm to base 2 x to power 2 over 6, which is equals to 2. Now, our next step, we are going to make some appropriate substitutions. So what we're going to do here, we're going to say let m be equals to the logarithm to base 2 x raised to power 1 over 6. And so if we are going to do this substitution and then we are supposed to rewrite the equation above, then it's actually going to be logarithm to base 2 x, and we're going to have 1 over 6 and then with a 2 outside, so a 3, and then plus logarithm to base 2 x, we close the bracket, 1 over 6, 6, and then we have another bracket, 2, which is equals to 2. Now, what we have inside here, we are going to replace it with m. And therefore, we can write this one as m to power 3 plus m squared will be equals to 2. And now we have transformed the logarithmic equation to a polynomial. All right. Now our next step from here, we are going to solve this polynomial equation, m to power 3 plus m squared minus 2 is equals to 0. Now it's not easy to get factors here, but the easiest way we are going to do it, we are going to use the rational roots theorem, whereby we are going to consider the coefficients of the leading power and the constant. We look for the factors. So usually in the rational roots theorem, the leading coefficient here, we call it Q, and the constant P, such that now in the rational roots theorem we say for any polynomial we are going to have at least one factor if we have all the factors of plus or minus P divided by Q. Now, in this case, therefore, we are going to consider all the factors of 2 minus 2 over 1. So the factors are actually plus or minus 1, plus or minus 2. Now we are going to try n of this randomly and see if it's going to be a factor. And in this case, we are going to use the factor theorem to do a random substitution up there. So let's say, for example, if m is 1, So in this case, where we're having m, we're going to replace it with 1. So we have 1 cubed plus 1 squared minus 2. Actually, we are very lucky. We have a 0. So what it means, therefore, in this case, it means m is equals to 1. We are very lucky. We have one of the roots as 1. Now, next we are going to use synthetic division to find the other roots. So we write the factor that we already have here, m as 1, and then we are going to write the coefficient. The first coefficient here for m cubed is 1. The coefficient for m squared is 1. We do not have m, so which means therefore the coefficient is just 0 and the constant is 2, negative 2. Now, for synthetic division, what we do, we drop this first coefficient down here, and then it's going to be 1 times 1. You multiply by this 1 here, the answer you are going to get is 1. So you write 1 here, 1, and then when you add, you're going to get 2. Then this 2, you multiply by 1, you're going to get 2, and that's what we're going to write here, 2. So 2 plus 0, 2 plus 0, in that case, we are going to get 2. Then next, it's going to be 2 times 1. We are going to get positive 2. So 2 times 1, the answer you get is going to be positive 2. So when you add, you are getting 0. And what we have down here, 1, 2, 2, these are the coefficients. These are the coefficients of the quadratic equation. So therefore, our final answer is going to be m squared plus 2m plus 2. Now we are going to factorize this further so that we are going to get the remaining roots of the equation. Okay. Now our next step is to factorize m squared. M squared plus 2m plus 2 is equals to 0. But if we check this properly by looking for the discriminant of this quadratic equation, we are going to realize that it's going to be a negative. So that is b squared minus 4ac. So our b squared is 2 squared minus 4 times the coefficient of a is 1 and the constant c is 2. And the answer is going to be negative 4. Since the discriminant is negative, it means that for this quadratic here, it means we have no real roots. Therefore, for the cubic polynomial that we had, the only solution that we're going to work with is m is equals to 1. Now we go back to the logarithm function, whereby we said the logarithm to base 2 x raised to power 1 over 6 is simply equal to 1. Now to get rid of 1 over 6, we're going to raise this 1 to power 6. We also raise this 1 to power 6. So our next step, we are going to have the logarithm to base 2 x is equals to 1. So removing the logarithm, or rather writing it in exponential form, x is going to be equals to 2 raised to power 1. And therefore, our final answer is x is equals to 2. Okay, thank you so much. Thank you for watching Math Companion. You are invited to subscribe and also to press the notification to get updated on every new challenging problems we come with. Thank you for watching. Bye bye.